Are you bored of just the plain old DIY 3D printer kits that you buy off the shelf? Maybe you're looking for a new challenge and you want to build your own 3D printer or design one from scratch, but you've got absolutely no idea where to begin. Well, I'm really excited to share with you guys a printer design that I've been working on for a little bit of time now, and I wanted to take you guys along for the process. So let's use this as a chance to learn together and hopefully avoid some pitfalls, and we can go over some of the things that I've done to my 3D printers in the past and things that I want to change or implement in the new design so I can make this printer the highest performing and most versatile printer that I can think of. I'm Todd with 3XD Tech. Let's get started. I want to jump into something that I'm really excited to share with you guys. It's a printer design that I've not just been designing, but I've also been trying to take bits and pieces from other 3D printers that I really like and want to put together and kind of make like a conglomeration or a cooperation, a coagulation, compilation. I wanted to make a compilation of different printers that I liked certain features of, but however, I couldn't get them all into the same printer without just taking it and designing it myself. So I started with an Ender 3, and I did all the 3D printed mods. You know, I printed all the belt tensioners, Z-axis mods, the bed mods, built-in enclosure, and it's pretty much done. There's a few things I would like to add to it, but I kind of wanted to get started working on this new printer because it's going to take all of the things that I learned from the original Ender and 3D printing in general, but there were some design features on a lot of the Core XY printers that I've seen that I'm not exactly a fan of. All right, so I think the easiest way to jump into this is gonna be for me to just pull up Fusion. I'm gonna start with my Ender 3. I'm gonna go quickly run through the mods that I did with that, maybe a little bit of explanation about why I did them, and then from there, we'll be able to take that experience and apply it towards the new 3D printer designs and kind of go from there. All right, so let's jump in. And this is my current Ender 3, essentially as it stands now with the mods on it. Let's talk about the Z-axis first, because I think that's the most modded part of the printer itself. I went to the MGN 12, I added the holes that I needed, and I printed this as a template. Drilled some holes and it was ready to go. All the holes were straight, lined up where they needed to be. You're fully constrained, so it's not gonna move or you're not gonna have any kind of issues. It does take a little bit longer to get everything lined up because it has to be dead straight or you're gonna get binding way worse than you would with wheels. The next part of the Z mods, I went to a ball screw setup with the mounts that I just designed here. I designed it to be 2-piece mounts because they're easier to print instead of making one big complex shape. And so I know that once this part right here was printed, it was real easy to move and make adjustments to this part if something was off. So if you look here at the mounts, these are the actual EK and EF blocks that you can get either made out of metal or you can get them from Masumi for, you know, $300–400. They're insanely priced. Since they're not really carrying a large load, I'm okay with this. So I just modeled them up in CAD, printed them out, made the blocks the same, you know, the regular bearings that go in there. The last thing about the Z-axis that I'll mention is that I did buy a new piece of extrusion for this, and I cut it a little bit longer because the original SFU mounts would not have lined up because the mounting hole for them wouldn't have worked with 2040 extrusion. So I extended this by about 25 millimeters on each side. Now they bolt up and I can get a little bit of adjustment left to right just to make sure that that ball screw is lined up straight. Y-axis doesn't have any mods. I mean, it came straight from the factory. The bed is square. I don't have to worry about any of that. I guess we can talk about this. Let's get into this real quick. Went to a direct drive extruder. I had the Bowden tube dialed in real nice. It worked great, but wanted to go to direct drive just for simplicity, flexibles, and just easier to mess with retraction and things like that. This mount right here, BL Touch mounts underneath, just a couple screws. I actually ended up having to use heat inserts right here just because the holes I made are a little bit too small. In the future, I'll make it smaller if I ever have to reprint one of these. Use the Prusa fan mount that everybody uses, because, I mean, Prusa uses it, so it's gotta be good, right? So that's all the mods that I've pretty much done to my Ender that I can think of. It is in an enclosure. Now after we can see it in CAD, let's go check it out. Let's do a step-by-step and see some of the features that I wanted to do in this new build, and some of the things that I plan on changing or have updated in my design. So number one, I wanted to make sure that it had no printed structural parts. Typically where a lot of the printers, example like the D-Bot, which was the first printer that I built from scratch, mainly because of the way that the parts are mounted together and they're 3D printed, that allows for a little bit of flex because you can't get a solid mount on a 3D printed part. I wanted to stick to a fixed frame design, so I wanted to have the brackets be able to metal contact along with metal brackets to hold them all together. Number two, I wanted to implement tool changer. The idea of tool changing to me has always been exciting. I've liked the idea of being able to swap different nozzles or hot ends without having to worry about it. Example, if I wanted to make a small intricate print, I could just have it pick up a small tool head with a small nozzle, and then it will be able to print real small fine details. Or if I would have printed things like this that I printed with a 1.2 millimeter line width and a 0.8 millimeter nozzle, being able to swap between those fast and without having to change profiles too much, I think is going to be the key for what I want to make this machine used for. I wanted it for the flexibility, and I also really wanted to start messing with the soluble supports. I think the idea of having to, if you have to use supports, having it being able to print a different material with support will make it so that it's a lot cleaner. The 3D print will come out with a higher quality, along with still being able to retain all the strength. Having a dual extrusion machine or a tool head changing machine seems like a prime opportunity to try something like that out. Point number three for this printer is that I really want it to be easily enclosed. I want it to be able to just bolt panels onto the side where possible, because I like being able to print in an enclosed chamber for not only one, keeping the heat in because I have the 3D printer in my room. I wanted to keep a lot of the heat inside the enclosure to prevent warping because I print a lot of ABS and polycarbonate. Point number four, this is where I had to start designing things on my own. I really wanted to make it, the parts were multi-part and easily printable. Example, if you look at the Voron design, the Voron's a great design because it uses multiple small 3D printed parts that are bolted together, but all those parts are easily printable because of the fact that they use either 45-degree angles where needed, or they're printed flat surfaces down, there's minimal overhangs and things like that. Because a lot of the designs out there are great, but they use a lot of support material to print. Maybe it's just more of an aesthetics thing for me. Point number five, the last thing I wanted, is I wanted to make this design essentially future-proof and expandable. So to accomplish this, I went with an SKR GTR because it's a 32-bit board and it's moderately priced. I also added on the M5.0 expansion board. So with the expansion board, it has multiple stepper driver slots, which means I can run a lot more extruders, which will be a lot easier to implement for the tool changer design that I'm going for. But more on that in a later video. Yeah, those are the 5 main points that I wanted to stress in this design. All right, so for the next video, we're gonna get into the frame design and actually start building the 3D printer. Make sure you subscribe if you don't wanna miss any updates on that video and any of the future videos, or make sure to click that like button if there's something that you actually enjoyed for this video. Thanks for watching, I'll see you in the next video.